Hi, welcome. In this video, we will solve problem 2 sum asked by companies like Bloomberg, Spotify, and Uber.
Let's check out this problem. So before we start solving it, I want you all to pause the video, go through the problem statement, understand output and input, and understand how output is coming from the input. So let's start this problem. So you are provided with a series of Q queries. So you can understand it as this is one of the query. And you are given a list of containing n numbers. So these are my n numbers and a target sum k. Okay, this is my target sum. Your task is to write a program that return yes if there are two distinct elements in the list that adds up to k. So we need to find two numbers that the sum of two numbers should be equals to k. And if it is, so we will print yes. If not, we will say no. We will return no. So let's start. So here we have n equals to 6, that is how many elements in the list, and the target sum is 9, and this is my list. So I will use this as a list here, and let me add the numbers. So 1 5 7 3 4 6. So I want to know, like, are there any two numbers that adds up to k, that is 9? So here we have 5 and 4. So we have 5 and 4 that adds up to 9. Then we have 3 and 6. Yeah, so these are, I'm getting two set here. Okay, don't think like these are two sets of numbers. We just need to find like is this list containing two numbers that adds up to k. So yes, we have two sets, so I will simply print yes. Okay, and even if there is only one set, then we can print yes. We don't need to return the numbers, right? It's only print of yes or no. Now let's check out this example. So here we have n equals to 5, k equals to 15, and let me use this again as an array. So here we have only 5 elements, so what I will do, I will simply remove one of it. Yeah, okay, so let's put the numbers first. 1 5 7 3 6, and if I check here, even if the highest numbers, you can say the like largest value number, that is 7 and 6, even if add this one, that will be 30, right? So we can't get number k equals to 15. So the output is no, and like there are not two numbers that adds up to 15. So now let's understand how we can solve this problem. First of all, we are clear with the problem statement, and let's start solving it. So I will use the same array. I guess this is good one. I will simply copy it, paste it here, and yeah. So here we have an array of, let me put the numbers here, that is n equals to 6, k equals to 9. So one of the basic approach, or like the first approach that comes to my mind, is the brute force one, right? So what I will do in brute force here, that I will take one number, one element, and I will search for the second number throughout this list, right? So I'm taking one and I'm searching for all the others numbers, right? So I'm not getting here, then I will take again one number and I will search throughout this complete list, right? Then I will get 5 and 4. So what will be my series here? So I will take first as you can say 1 comma 5, then I will take 1 comma 7, then I will take 1 comma 3, then I will take 1 comma 4, then I will take 1 comma 6. Now the numbers with 1 done, then I will take 5 comma 7, then I will take 5 comma 3, then I will take 5 comma 4, and here we are getting the sum, right? 5 and 4 are the two numbers that adds up to k, that is 9. So this is one possible approach, right? Although this is the brute force one, right? I need to iterate through all the elements from the list, but this is an guaranteed solution, that here we will get a solution, that is sure, right? So guaranteed solution, right? But although the approach is the brute force one, so our first approach, that is the brute force approach. Brute force approach means we are exploring all the elements, all the numbers, right? We are going with maybe repetitions, but we want a solution, we want a guaranteed solution. So by this, yeah, we can expect one solution here. So the same thing will go like by this one, then this 5 by 4. Suppose if I continue this, so it will be 5,6, and so on. In the last, we will have 4,6, right? And if I say before that, we will have 3,4, 3,6, like this, right? So here we will get different sets of two numbers, and then we will get a solutions. So if I say, let's see how we can. So I will simply show you a small piece of code, right? So here if I say, I will start my for, I will use one of the loop that iterate from each one of the element. So suppose I will start from 0 to all the elements, that is n, and then I will use one more loop, maybe j, that will start from I plus 1. Remember, if 1 is there, then I will start from 5. The first element will be 5, not 1. So I plus 1 to n, and then we will simply check like if sum is equals to k or not. Okay, so here you can see I am using two loops, right? And inside the loop, one of the loop, the condition will be same, like if sum is equals to k, then print yes or no. So here you can see I am iterating through n elements here, right? And here I am iterating to simple n minus 1, if I'll say, right? So for each one element, right, suppose 1, I am iterating to this n minus 1 element. See, 1 5, 1 7, 1 3, 1 4, 1 6. How many sets? 5. Now for 5, I am iterating through all the other elements, right? That is 1, 2, 3, 4. Right? So here you will see your solution will be, the time complexity of your solution will be of big O of n square, right? Because first there are n sets, then there is n minus 1, then plus n minus 2, and so on. If I go like, it will be like 3 plus 2 plus 1, and you know this series, right? This is series of n into n plus 1 by 2. So here you can see n into n minus 1 by 2, and then this series will be n square minus n. And if you know a little bit about time complexity, then we can simply ignore the constants, and the time complexity will be termed as big O of n square, right? If you want to understand more about time complexity, you can check out my other videos on time complexity, and yeah, this will be your time complexity. So now we know the brute force one. Let's try to optimize the little. And whenever I am saying optimization, always think optimization comes with the observations, right? So we need to focus on the observations. So let me copy the same one and let me paste it here. Just, yeah, now it's okay. So this is my set, and I want some of the observations here. This is my simple array. If I put indexes, still I am not getting any sense here. So what we will do, let's try to sort this array, right? So let me put that this is my basic list or array, right? So what I will do, I will simply sort it. So I will simply copy this one, and let's see if I can paste it. Oh, so it is not pasting good. That's an issue with open board. So So let me simply this one, and now I can copy paste it. So if I sort the array will be like 1, the smallest number, right? Then the next smallest number is next larger number, that is 1, 3, 4, 5, 6 and 7. This will be your sorted array. You can say sorted list. Okay. Now let's observe. Can we get any type of observations here? So what I will do, I will try to just build a graph of it. So suppose this is representing as 1, this is representing as 3, this is representing as 3, then this is representing as 4, this is representing as 5, 6 and 7. Okay, and let me put the indexes here. 1, 2, 3, 4 and 5, and let me put the values here. 1, 3, 4, 5, 6, 7. So here, as we can see, there is one trend. So if I am moving here, my values will increase, right? Yeah, this will be good sign. And if I am coming here, my values will decrease. Okay. So now what we can do, let's try to do one sum of two numbers. So I will take this number that is here, the first the minimum element and the maximum element, right? So the sum of minimum and maximum, that is 1 plus 7. Okay, so let's put sum here. Okay, the sum of first and last element, right? You let me denote with some pointer. So I will use left pointer, so I am using L here, and I am using R pointer as R, and we will see some observations, right? So here my sum will be, basic sum will be equals to array of L plus ARR of right. This will be your sum. Now let's understand what are the possibilities of this sum. Remember what we need to find. We have n, okay, we have n equals to 6 and k equals to 9. So we need to find a sum of equals to 9. Right now the sum is 7. So here there are three possibilities. Let me quickly show it. So if you can see, if you can observe, your sum here can be less than k, your sum can be greater than k, or your sum can be equals to k. So if it is equals to k, what we need to do? We don't need to do anything else. We just need to print yes, right? Now let's see if my sum is less than k, right? So what I supposed to do, right? So if my sum is less than k, I should increase my sum. So if you have two pointers, right? If you have two pointers L and R, in which direction you should move? Towards right? If you are, because we are saying values will increase when we move right. So I should move in this direction, right? I should move in the right direction. So which pointer I will use? I will use L pointer, right? So I will simply move my L pointer from here to here, and I will check the sum, that is 7 plus 3, that is 10. So can I say I am moving my L pointer one by one, 0 to 1, then 1 to 2. So remember, L pointer is denoting your indexes. So here L I will say L is equals to 0 and your R pointer is equals to 5. That is your n minus 1. What is n? 6. 6 minus 1, 5. So you are moving your L pointer. So if I say sum is less than k, I will simply do L plus plus. Now what is my sum right now? 10. Alright. The sum is 10. 3 plus 7, that is equals to 10, which is greater than k, right? I just want 9. So I should decrease the sum. And in which direction I will move to decrease the sum? Left direction, right? So if I'm moving in left direction, I will decrease the sum. So can I say my R pointer will move from here to here to decrease the sum, right? So I will move here and I will say R minus minus, because from 5 it is coming to 4. Basically L plus plus means L equals to L plus 1, R minus minus equals to R minus 1. Now you can see what is the sum. 6 plus 3, that is equals to 9, right? And this is what we want. So we are in this category, and then we will print yes, right? So this is what your two pointer approach is, right? So you can see some of the videos on YouTube like two pointer technique. Let's understand the two pointer. Two pointer is nothing, right? Two pointer is just an observation. Observation from where? When we have a sorted array, just see the trend. So what, like any researcher or like any mathematician simply sort this array and they just found a trend basically. So if we are moving towards right, the values will increase. If we are moving towards left, the values will decrease. And this is what two pointer is. Two pointer technique. So these are my two pointers, L and R. Okay. Now let's understand it more better. So I will simply copy this and will paste it here. And let's take an different example. So instead of this 6, I will simply put 10 here. So we want to get 3 plus 6 for the solution. That will be a 10. And let's, if I sorted it, so this 6, okay, yeah. So if I sorted it, my 7 will come here and then 10 will come here, right? This is my sorted array. Okay, let me put the values again. So n is 6, remember, and k is 9. Okay, so how you started basically? So you started like this. So you have taken an array, you have sorted the array, taken two pointers L and R. So I will use L here, that is L pointer, R pointer, and you started with sum because you will take sum, right? So right now the sum we will check. So L pointer is pointing to 0, right? R pointer is pointing to 5, and if I take sum, that is equals to ARR of L plus ARR of R. What is the sum? 10 plus 1, that is 11. Okay, now the sum is 11. What will be our action? What is our action? What we will do? So this 11, it's basically is greater than 9, right? 9 is k. So what we will do? We will decrease the sum. So we will move R pointer. So my R will be minus minus. So R will point to here. So now L is still 0. R is pointing to 4. Now what is the sum? 1 plus 7, that is equals to 8. 8, which is less than 9. So what will be our course of action? Right? I want to increase the sum. So it will be L plus plus. Right? Now L plus plus, I will move my L pointer here. So now L is 1, R is at 4, right? And what is the sum? That is again 10, right? So 10, which is again greater than 9. Now what will be our course of action? Decrease the sum. So I will do again R minus minus. So if I am doing R minus minus, my R pointer will be here. So now L is still at 1, R pointer is at 3, and what is the sum? 3 plus 5, that is 8 again, which is again less than 9. So what I will do, I will increase the sum. I will move my L pointer, that is L plus plus. My L will point here. Now what is the sum? L is pointing to 2, R is pointing to 3. The sum is 9, which is equals to 9. What we will do? We will simply print yes. And that's it. Now suppose if we are not getting sum, right? If we are not getting sum here as well. So suppose instead of 5, it is something like this. What I will say? It should be less than, it should be between 4 and 7, right? Sorted array. So let's put 6 here, right? And we are just excluding this case 6 plus 3. We are just thinking that we are not getting any solution. Okay, just think that we are not getting solution. This could be 2, right? Or should I choose a different example, because maybe it can create a confusion. So what I will do, I will simply remove these numbers, or let me show you one different example where we don't have any solution. So now let's check out the same example that we were in sample input and output. And so the numbers were 1, 5, 7, 3, 6, where n is equals to 5 and k is equals to 15. Okay, so if I sort this array, so my sorted array will be, so 1, 3, 5, 6 and 7. Okay, now let's apply the 2-pointer technique here. Right now you are aware of it. So how you will apply that? L here, R here, remember? Okay, this is the first class of 2-pointer technique. So maybe we are assuming that L should always be 0, R should always be n minus 1. No, this is not true. 2 pointers are only 2 pointers. You can use wherever you want. Okay, we will see in some different questions how we can use pointers in a different way. Also remember, this is not true that for 2-pointer the array should be necessarily sorted, right? There are some cases where the array is not sorted, but still we can apply 2 pointers, right? So let's start. So here my L, R, we will take sum here, and then we will take action. So L is starting from 0, R is starting from n minus 1, that is 4. And what is the sum right now? So 1 plus 7, that is 8, which is less than k, right? So let me put the 15 here. So what will be my course of action? Simply increase my sum, do L plus plus. So I will move my L pointer. Now my L is pointing to 1, R is pointing to 4 only. And what is the sum? 7 plus 3, that is 10, which is still less than 15. So I will do L plus plus again, right? Increase the sum. So my now L pointer will be at 2, right? R is still at 4. What is the sum? That is 12, which is less than 15 again. It is L plus plus, and I will move my L pointer here. Now what is R is still at 4. What is the sum? That is 13, right? Which is still less than 15. Again you will do L plus plus, right? Now your L pointer will be here at 4, right? And here the sum is 14, which is less than 15, but you can stop it here only, right? Because now these are not two different elements. Remember, both the indexes are pointing to the same element, right? Both my pointers are pointing to the same element. I want two different indexes, two different elements, right? So we can stop it here. We can stop it here and we can simply return no, right? Also, like if you go with this series, L again continue moving, and you will end up say that no, but still like you can end it up here. So if your L and R both are at the same end, if suppose here in the question we want two different elements, if the question is saying you can check the same elements, or you can count the same, like the same number of elements, then it's fine. Okay, so here the answer is no. And what we got to know from here, that in both the cases, the previous one and here, the starting condition, what was the starting condition? So the starting condition or starting point, I will say, was when my L is at left side, so 0, and R is at right side, that is n minus 1. And what is my stopping condition, or when I stop? Basically here I stopped, right? So whenever my L is going greater than or equals to R, I will simply stop at that point. Okay, you can also say this is your stopping condition. Okay, so you got some of the few points, right? This is that how we can start our variables, these two, how we can stop our variables. What we need to do, we just need to calculate the sum and what will be the actions. So in the next video, we will sum up all these and we will create a code of it, right? So then I will show you how your observations, how your approach will sum up to make a code.